Note that you do not necessarily need to determine R² for the data. Why not? Well, first, when determining the linear range, you are not going to use the entire data set, only a subset of the data. Secondly, R² doesn't tell you how linear your data set is. It actually describes variation. R² is the symbol for the coefficient of determination and is a measure of how well the regression line or trend line represents the data. Take a look at example A, where temperature in Fahrenheit is plotted against temperature in Celsius. The regression line or trend line passes exactly through every point. The linearity of the trend line is perfect, so R² equals 1. What this actually means is that 100% of the variability in Y, which is the temperature in Fahrenheit, can be explained by X, the temperature in Celsius. It is important to note that while R² equals 1 for this trend line, the data are not proportional. If you look at the Celsius scale and double the temperature anywhere on that line, say from 10 to 20 degrees, the difference in Fahrenheit goes from 50 to 68 degrees, not 50 to 100. Now look at example B, where the number of bottles of water sold are plotted against temperature. The data point values vary above and below the trend line. The R² of this trend line is 0.850, which means that 85% of the total variation in Y, the number of bottles of water sold, can be attributed by X, the temperature, but that 15% of the total variation in the number of bottles sold is not due to temperature, but to something else. So, applying R² to your data for linear range determination really only tells you about variation in signal intensity that can be attributed to your sample protein concentration and variation that is caused by something else.